Okay, we're back. 1.9 on Techmath1. We're looking at number 80. This is writing large numbers as exponents, base 10 numbers. 1 billion. So look, 10 million, that would be 10 to the 7th power. Because remember, when you multiply 10, that just adds a 0. So if you take 1 times 10 times 10 times 10 times 7 times, that's 1, 2, 3, 4, 5, 6, 7 zeros you add. This is 1 billion, 1 billion. Dr. Evil. All right, 10 to the 9th. Let's jump to 82. What if I do 10 to the 1st times 470? What if I do 10 to the 2nd times 6.08? What if I do 10 to the 3rd times 6.5? So look, all you're doing, 10 to the 1st, I'm just moving it the decimal place one place to the right. So that's 470, or adding a 0 in this case. 2 places to the right. 3 places to the right. Okay, so we're moving the decimal on these two. This one, the decimal was right there. We still move the decimal, but that's also equivalent to just adding a 0 to it. So 2 places on that one because it was 10 to the 2nd. 3 places on that one because it's 10 to the 3rd. All right, I'm sure this isn't new for anybody. 87. What if we go the other way? Now, this might be something you didn't really think about. 1, 2, 3, 4, 5, 6, 7 zeros and a 1. Let's see, 1 point, 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros and a 1. So now this time, if I want to move the decimal from here to there as a base 10, to write this as a base 10, it would be 1, 2, 3, 4, 5, 6, 7, 8 places. So 10 to the negative 8th power. We could do that by reading it aloud correctly. This is tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 millionths, 100 millionths. So I could say 100 millionth would be how you would read that correctly. And so think about that. 100 million is going to be 8 zeros on the bottom. Because look, 7 zeros was 10 million, right? All right, so this one, let's go with 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. But then it takes at one more place, the 10th place. So 10 to the negative 10. All right. And then I wanted to jump to 92. Let's do, so this is just kind of fun with powers of 10. We're going to do scientific notation on 1.10, the second part of this video. All right, so we got 72 times 10 squared, so that takes the decimal 2 places to the right, so it's 7,200. We got 72 times 10 to the negative 2, so that takes the decimal 2 places to the left. We got 0.72. We got 0.48 times 10 to the 4th, that'll take it 4 to the right, so 4,800. We got 0.48 times 10 to the 4th, that'll take it 4 to the left, so 0.000048. All right. Okay, let's look at scientific notation. Again, I'm sure this isn't your first rodeo where this isn't probably the first time you've ever seen or heard of scientific notation, but we'll go over a few problems just to refresh your memories. Scientific notation is used when we are using very, very large numbers, very, very small numbers. And so as science advanced and we started figuring out things like how far planets are from us and inventing microscopes to see things that are magnified many, many, many times, we could look at really large and really small numbers, but they're very hard to write out. And that's actually what we're going to do right now. So look, 7.13 times 10 to the ninth. To be in scientific notation, it has to be a number, the starting number, the lead number, is always between 1 and 10. So it's got to be a number and then 0.13. So look, it couldn't be 71.3 times something. It couldn't be 0.713 times something. Then it's not in scientific notation. Scientific notation, the lead number is always between 1 and 10. So we take this decimal, according to this, and move it. This is a very large number. We're going to move it 9 places to the right, but 2 places are already taken up. So I'm actually going to write 713, but then I'm going to add 1, 2, 3, 4, 5, 6, 7 zeros. So here, let's see how big that number is. That is, what is that? 7,130,000,000. All right. You don't say the word "and" when you read a large number. "And" signifies a decimal point. Think about when you pay with money. You say the bill came to $47.37. And means that decimal point. All right. Remember where the decimal is here. It's 5.0 right now. So I'm going to take this 10 places to the left, but that's going to, one of those places is already taken up with the 5. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, and then the 5. So the decimal was here, and I moved it 10 places to the left. So that's a really small number. So that's a really large number, really small number. It's much easier to express it in scientific notation because then you don't have to, count zeros every time you write the number down. All right. It's also easier to compare very large and small numbers because you can just look at the exponents. 99, we got 2.998 times 10 to the 8th. And we got 1.7 times 10 to the negative 7th. So let's take a look at that. This moves it 8 places to the right. So 3 of them are taken up already. So we're going to add 1, 2, 3, 4, 5 zeros. Because look, 1, 2, 3, 4, 5, 6, 7, 8. And then after you get that decimal ready, we can count out by 3s. So that's 299,800,000. What about a really tiny number here? This is 7 places to the left, but the 1 takes up one of those places. So we keep counting. It's 0.000000. 1, 2, 3, 4, 5, 6 zeros, a decimal, and then 6 zeros, and then a 1, 7. All right. And then, that was the diameter of a molecule. This is what I meant by the scientific discoveries that we made where we had to figure out a way to write these numbers down without doing all these zeros. Look at that. A light year. So the distance traveled in 1 year by light. Light travels pretty fast. So now look, this is how fast light travels. Let's take a look. 5,870, 000, 000, 000, 000, miles. Dang, in 1 second. That's how fast light travels. That's why it seems instantaneous to us. You have to flip on a flashlight and it's like instant. But this is actually how fast it's going. This is number 100. All right, so let's write that in scientific notation. So I want this number to be between 1 and 10. So I'm going to put the decimal right there. So I want it to be 5.87, and then it's going to be times 10. And now I got to figure out how many places I moved it from where it was to where I moved it to. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. So 5.87 times 10 to the 12th miles in not in 1 second. That's how long a light year, the distance light travels in 1 year. Not 1 second. What am I thinking? 1 second. Jeez. 1 year. This is how far it travels in miles in 1 year's time. Not, geez, I had it way off. I said in a second. No. In a year, in 365.25 days. That's how far light will travel. So that's still really far. That's the light that you see from stars that are reaching us now. It's like traveling in time because it took so long to get here. What do we got here? 8. 1, 2, 3, 4, 5, 6, 7, 8. So point and then 8 zeros and then 481. So now we want to get this to be a number between 1 and 10. So 4.81 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, -9 power. We wanted it to be between 1 and 10, so we had to get it between the 4 and the 8. And then we counted out 8 zeros, but then there was still a 9th place to get it there. So that's why it's to the -9. Really small numbers will have a negative exponent. Really large numbers will have a positive exponent. And yeah, sorry about the second thing. That's how far light travels in 1 year, thus a light year. So, it's late for me. I know you're just watching the recording whenever you're watching it, but I've had a long day. Sorry about that mistake about the science thing.